All right, y'all. Good evening. Good evening. Happy Sunday again. We're ready. We are rolling this March. I told y'all last weekend we're back. Very excited to be back. And y'all know I like to get right to it. So we're going to jump right in. This evening, we're focusing on what's happening because you've seen it before, whether you're in the classroom, excuse me, or at home, you've seen it where maybe your child, a child that's smart, stalled, like something happened, right? They're not producing the same responses. Maybe they're hesitant. We're going to talk about what's happening. First is a hidden math confidence problem, but I just want to be super clear. Y'all know we're going to make sure that we talk about how to keep their identity, their math identity, their identity period intact, right? And develop it, build it up from there. And just being super clear about how these gaps, right? If there's some gaps that came up, how these gaps developed, and what to do about it. Here we go. All right. So, first of all, y'all let me know. Talk to me first. Have you ever watched your child look at a math problem, watch the student look at a math problem and say something like, "Oh, I used to know this. It's hard now, right? I used to be good at this. I'm just not a math person, or I just don't get it anymore." Does any of that sound familiar to y'all? Anybody? Maybe so. Okay. Y'all let me know in the chat if that sounds familiar to you. But also, while they're articulating that, while they're saying that out loud, you might be thinking to yourself, but you are smart, right? You are good at this. So in that moment, right? I call that a math stall, y'all. So smart children do stall sometimes when their identity becomes fragile, when they aren't sure, when the confidence is a little rocky, basically. So from here, a couple of things, y'all. Last week we talked about pressure versus precision. If you missed that, y'all go back and catch that one. But tonight we're going one layer deeper. So we're talking about and elaborating on. We said pressure really increases during testing season. But what happens at home, right? So beyond the classroom, parents start seeing stalling, right? They might see some hesitation. You might see avoidance, like, no, I don't want to work on it. You might see some frustration, or frustration can be expressed in a lot of different and very big ways, right? Or you might even hear, I forgot how to do this. So a stall, a math stall, those moments is rarely, very rarely about ability, and it's usually about identity. It's usually about identity, how they're seeing themselves or not in math. Okay. So I have a quick statistic for you, a quick stat. Now, research shows that about 67% of students report stress during testing periods. And I was like, well, yeah. I'm like, and actually I think that number's a little low, right? So let's give it some context. Let's talk about it a little bit. Let's ask some questions about these numbers. So if 67% of students report feeling some type of stress during testing periods, so this is data from organizations that focus on the emotional well-being of students and their education. They ask a lot of different surveys about that. But if we get more specific to certain ages or grade bands, we call it, 70 to 75% of high school students report stress related to schoolwork, period, not just testing periods and exams, right? So in general, and that's the APA that reported this, the American Psychological Association, when they were testing and reviewing data on teens and their interaction with school and schoolwork. But then if we look a little more closely again, then the data shows across the board that 80% of students report test anxiety at some point. At some point, 80%. So with that, y'all, stress changes how students approach their problems. And I mean, it's math. So there's going to be problems on purpose, right? So when confidence drops, students stop experimenting, right? They stop trying to figure it out. Students stop explaining their thinking, and students stop taking risk when their confidence is feeling challenged, right? When their identity is in fragile mode. So we talked about this way back in October, right? During the month of the parent. What happens when we're stressed, how stress impacts thinking. Because we know it's difficult to think clearly when you're stressed because your survival mode activates. So a very nerd moment, Maslow's hierarchy of needs, where it talks about the basic needs. We need food, shelter, right? The very, still at the foundation, right? Base level, still at the foundation, very close to the bottom rung, the bottom layer is safety and security. So this math problem, this task you gave me, right, is getting a little iffy because at this point I feel as though my safety and security are being jeopardized. They're being challenged right now by this. So survival mode activates. I am not worried about this problem you're trying to give me. I don't know how to do it. Oh, I forgot. So all of that is happening because neuroscience piece, the brain is going to protect identity. The brain is going to protect identity before it protects performance. So you want me to perform this task? I'm just trying to make sure I'm okay right now. That's exactly what happens. All right, check it in. So true, stress changes how students approach their problems, if they approach it at all. As we talked about, it can be an avoidance, a hesitation, a shutdown, a straight up, well, I don't know, I just forgot. And it could be true because the brain is not even trying to access that information at that point, right? Thank y'all so much for tuning in. Thank y'all. Yo, so what we're going to talk about though is, okay, if the brain is protecting identity first before performing a task, answering this question, so then what? Like, what do we do about that? What does that mean, right? So we referenced a little bit last week also the CRA, right? These math layers, these phases of learning math specifically. CRA, C being concrete, R being representational, and A being abstract. Yeah, what that means, usually, I would say 9 times out of 10, if not 10 times out of 10, when math struggles happen, is because the concrete step one, and I'm gonna blink slowly. The yes, step one was rushed or skipped. Remember, we talked a little bit last week, and I said, well, if people are not doing the step with fidelity or they're skipping the step, then we're starting out the children at a 67%, right? At 67% rate of this is how you're supposed to learn math because they're skipping one of 3 steps. That's the step. Step one being concrete. That is usually what happens if some math struggle is popping up. So a couple of things. I want to give y'all some specific examples, and I'm going to show y'all a few things too. So for fractions, you know, a lot of times fractions are one of those big moments, big deals where students are like, I don't even know what we're talking about right now. Right now we're drawing these lines and we have parts and wholes, pieces and all this. I don't know what's going on. That happens if students don't get to experience fractions first with actual objects, with things they can touch, right? That's what the concrete part is. Or visual models, they jump straight into some symbolic rules. Oh, this is a numerator, this is a denominator, right? This is how you make equivalent fractions. So all that ends up happening is they just memorize steps, but they don't understand relationships. So that's why you end up with students that sometimes will tell you, oh, Miss Jones, 1/6 is greater than 1/3 because they didn't get to play with it, right? They didn't get to build objects. They didn't get to use objects to build things and create. And so they don't understand the relationships inside of the fractions. Okay. Another example, because I want to make sure we're really locking this in, right? With this concrete step, especially. So in algebra life, when algebra is introduced symbolically, right? Someone last week talked about, okay, now we have letters with the numbers, timeout, flag on the play, right? When algebra is introduced symbolically, just the equation written out without any visual reasoning, the students just start to think, I don't know what this is. I don't understand variables, but actually they missed the concrete part. What does that look like? Glad you asked. I'm about to share my screen with one of my most favorite Students that work with me directly, they know this website, they use it. I've convinced them even to benchmark it, right? They know, are we going to the pilot? Yes, we're going to the pilot pad. So, audience, YouTube audience, this evening, y'all are coming to the pilot pad with me. It is my most favorite website ever for kindergarten up to my high school students when we're doing algebra and things, right? So, someone said, now you know, you're talking about me as a kid missing the concrete. So, but listen, the one thing I want to do, and I was making a note for myself earlier, was to actually see if there's any kind of data on this, right? If there is a way to test people that are now adults, starting with Gen Z on up, because a lot of them are adults as well, right? Just to see, okay, if there's some challenge in their math identity, is it because some of the concrete pieces were missing? Right, just things in the back of my head, right? Not that I have all this extra free time at all, but just again, 9 out of 10, if not 10 out of 10 times, people miss that step. It was rushed or absolutely skipped over, right? They played hurdles with it. So let's talk about this algebra. Some of y'all are like, okay, looking at. Y'all, this is 3 different levels of things. So what happens a lot of times, some of us, maybe level 3 was the first thing we saw when we saw algebra. They just put an equation up. All right, we're going to start solving equations. And you were like, what? Right? Let me know if that's you in the chat. If as well as you can remember, when it was time to do algebra, that you only saw level 3. Let me know. Put a 3 in the chat if that's you. So I remember some letters and some numbers one day. Anika, that's all I recall. Someone said, I didn't really start understanding math until having to teach second grade. I didn't realize there was 3 ways to navigate: the concrete, the pictorial, then the abstract. Yep. So level 3. Yeah, but what if I told you there were some levels that should have happened before that? There were some levels that should have happened before that. For example, we're going to go all the way down to level 1. Let me put my little pencil down so y'all can see a little better. So if we were looking at, I'm going to use a little color, draw a little box. Y'all see where I love this, right? We color code things. We have a great time, the students and I. So if I put a box around this so y'all can see, let me move my bar down here and zoom out. There we go. So that is where we should have started. If I draw an equal sign right there, and now you're looking at nothing but pictures, right? You can look at it picture form in class life. You could literally have, okay, this is a rectangle and I have 4 circles, and this equals the same thing as 8 circles. What must the rectangle equal? What must be the value of the rectangle? If a rectangle and 4 circles on one side is the same thing, right, as these 8 circles, what is the value of the rectangle? And so we're asking these kind of questions, letting the young people see what they observe. And they're like, all right, well, if it's 4 and then the rectangle, did anybody figure it out? I'm talking a little bit, but I want y'all to answer this too as we process through. Right? But literally, we have the pictures, we have the shapes actually in class. What is the value of the rectangle? If we have a rectangle and 4 circles, balances out, equals 8 circles, what must be the value of a rectangle? Yep, 4. And so imagine though that we do this in kindergarten, in first grade, and a lot of times people forgot. We forgot, but this is how algebra starts, right? It's literally models and pictures first. This is how algebra starts. And you've been doing this for that long. You've been doing it for a long time. So then what happens is it becomes this: 4x equals 8, right? For the 4 circles, the rectangle, we didn't know the rectangle becomes x, but it equals 8. So that's its own skill too, to take you from, okay, y'all remember doing this with the pictures? Now we're just going to take some time and write the equation. We're going to understand what the picture is telling us. That's its own skill. That's its own skill. So we take time and do that. Y'all, and guess what? Like I said, that's level 1. Level 2 is when you're ready to start building yourself, right? And you're getting more comfortable with the variables, right? When someone said the letters and the alphabets were having a party in math class, they are. They having a party. But you're ready to start building and modeling the equations yourself. So this is where we would normally introduce what we call the algebra tiles, right? So you're used to the variables, those little X's there. Let me zoom in some so y'all can see these a little better. Right, there we go. So we can see the 3x, we see -2, and we see the 7, right? The positive 7. So what happens is literally from before, from level 1, because you would have done that for a while, y'all, for like a week or 2 in class, right? Just letting the students figure out, okay, if I don't know this one, well, maybe I can take the same number away and see what's left, right? Some students do that when they're figuring out. They'll say, okay, so if both sides have 4 on it, they'll do things like this, and they're determining and they're crossing out. They might cross this out, cross out these 4, right? And cross out another 4 over here. So literally all that's left is the rectangle equals 4. So from that skill, that's when we build it up. And it's like, okay, we've learned about some positives and some negatives. Where these, and we're using different vocabulary by the time we get into the integer negative number life, right? These are going to be 0 pairs. And I love, love, love polypad, because guess what? When you put that positive with the negative, it shows the 0, right? So y'all, just different ways to make sure you see the layers and levels and transitions for algebra. But again, you started in kindergarten, right? A lot of times, I'm going to share one more screen really quickly, because we shouldn't have started at level 3. We would have started at level 1, and there's some steps in between. Like I'm just saying level 1, 2, 3, but literally there's layers inside of the layers, right? If this is the concrete, there's certain things you want to make sure students understand at the concrete level before we start drawing pictures and using symbols, and before they're just given a straight up level 3 question at the abstract level, right? It's very specific things that are happening, very specific understanding that's happening before we just jump to the next level. So it's levels within the levels, right? Sometimes I'll tease the students and I'll say, okay, we're at level 1.5 right now. And they're like, all right, Ms. Jones, right? Because we're getting there. Also, just saying it that way, letting them know that it's a continuum. Like we're building up to something. We're going somewhere. We're doing something with this. And it can continue to go on. You're going to continue to do it in 7th grade, in 8th grade, in 10th grade. Okay? Letting them see the connections and layers that way. I'm going to play part of this video, but this is ideally, right, how you would start again. So still starting with the pictures, not the pictures, just the shapes that young people will actually touch.
For this problem, we
Oh, wait a minute, y'all. Where's my sound? Did I mute this tab? I'm good for muting a tab sometimes. No, it's not muted. Let me try again, though.
have 4 X's on this side.
And I'll kind of narrate a little bit. So he's modeling and he's using chess pieces, right, to represent his values, or something that look kind of like chess pieces. So the 4x plus 5 on the left side of his equation plus 2x plus 13. That's what he's about to put up.
13.
Okay. So
Now let's do the legal moves.
So he's even thinking about it somewhat like chess, right?
We
Like
take
legal
an
moves.
X
I'm
from
trying to
each
remove
side
things
and
that I
then
can. That's the
another
same on both
X
sides.
on
And that's
each
what we
side.
talk about and
Now we
eventually
cannot do
do.
that legal move
Right. So he
anymore.
removed
They
the
can
two
still do one
X's
more
from
legal
both
move.
sides.
We will take
So now
the
he
5
has
values
a
from
2x,
each
a 5,
side.
and a
So we
13.
take
So
this
he's like, all
5
right, if
and
I
take this
remove two
away,
variables at the same
and
time,
this
then I can remove
13
5 from this
turns into
13.
13
So he flips it
into
around and he's
an
going to
8.
place it on an
So
8.
now we need
Look
to
at
know
this. Now
two
he's like, two
numbers
of the
that equals
x's
up to 8.
equals 8.
So
So
it
one
must
of
be
them must
4 plus
equal
4.
what?
The
4.
x's must be worth
But
4.
literally solving
And
it
here's the button
by
to do the
touching
check.
and moving first. And
We
think
have
about how much
4
more,
x's on this side,
just not, not only
4
how
x's
much
on this
more
side.
sense, but just creating this experience for young people, right? Because that's what math is, experiences. When you create that experience, we'll say, remember that time when you built the equation? What was your first step? How did you start? Oh, I was trying to take away the things that were the same on each side. Okay, so let's talk about how that's going to look when we only see the equation, right? What it looks like, what it sounds like, we're moving things from one side of the equation to the other. Okay, so because we created that experience, though, do you know how rich the conversation becomes? And just again, what the kids can draw back on from their previous experience because we took our time with the C, with the concrete. Then we went to the representation, then the abstract. Let's see, what are y'all saying? Y'all cutting up. Polypad me. Indeed, labeling and organization is a missed opportunity. Definitely. Because especially the basis of the labeling and organizing, because so much when you get to middle school and geometry starts getting more dimensions, right? If we hadn't been practicing labeling and organization, it shows up that way. Someone said, I needed you as a teacher. Can we get a series on this? I need to pay. Okay, so listen. Okay, yes, we definitely will talk about it. So this is my first introduction to Polypad. So I might just do that one day, just give y'all a tour, and I'll give some insight as to what sections I use with different grade levels. Because like I said, I use it for kindergarten all the way up to 10th grade. There's so much stuff to do, y'all. And my students know that I love that it's benchmarked for them. Many, if I'm working with them regularly, they know, are we going to the polypad? We are, indeed. They already know. Because again, they have to have these experiences. Yeah, I can teach them anything after they had the experience because they've done it, they've moved stuff, they've touched stuff, it's locked in. Even if they make a mistake, right? So I talked about when students are building fractions and we're comparing like 1/6 to 1/3. And a lot of students at first, right, without the experience of seeing it and touching and building it, will say 1/6 is greater than 1/3. But, and I'll say, can can you go back to your polypad? When you looked at the size of the pieces, is 1/6 bigger than 1/3? They'll be like, no, it's not. And so then we get deeper into, well, I wonder why. I wonder what is actually determining the size of the fraction. How can we figure out how large or how small the size one piece of the fraction is going to be? That's a big deal. That's when it clicks. But they have to build it. They have to touch it, build it, move it around and stuff first. Okay. But yeah, so you know what? Thank you for saying that. Can we get a series on this? That maybe that'll be April, right? Maybe that can be some things in April for sure, or a bonus session. I can definitely do that because I do love to talk about the bottle bed. I really do. Okay. Also, when we're talking about multiplication, so y'all had a very detailed, right, example for algebra, but we're talking about just the language, right, and the way that we present these different concepts, like these big things. These are anchor moments: fractions, algebra, and multiplication, right? Those are huge anchors in your math journey. For multiplication and division, if they're only taught as facts, do you know your 10s? Do you know your 12s? Right? Versus groups and arrays, equal groups and arrays, the rows and columns, then students are going to stall when the problems become more complex. Again, so that means if they didn't see multiplication and division as groups and arrays, that means that they're going to stall, y'all, but The concrete was probably skipped then. If they aren't as familiar with arrays and the pictures and how to do the grouping, that means more time needs to be spent there if they're stalling. More time needs to be spent there. Um, Generally, if this is very insightful to you, you like it, you're like, okay, so these are the areas I need to go back to help my students strengthen this, and this is how I need to do it. Y'all, if this is insightful, you like it, there's literally a part of our spring reset toolkit. We have a vertical math skills for parents resource that is broken up by grade bands. It says, okay, for kindergarten through second, third through fifth, right? Sixth through eighth, and then high school. It talks about this is numbers and operations, the things happening at that age. And if they're having some issue, then review this. And that goes for each math strand. We have 4 areas of math. We call them math strands. So numbers and operation, algebraic reasoning, which y'all got a live journey, right? Geometry and measurement, and then the 4th one is data and probability. But we've organized it and are saying things in such a way that parents will be able to see, okay, if my child is in middle school and they're having some of these issues with equivalent fractions, let's go back. This is what you go back and review. So it literally rewinds the tape for you. All right, let's see. Okay, y'all are quiet now. I'm just checking on you. So, y'all, your child might be stalled, a student may be stalled if homework suddenly takes twice as long. Suddenly. You're like, what happened? If they're avoiding explaining their thinking, if they're starting to say, I forgot everything. I don't know. I forgot. Are they asking you for the answer quickly? They're like, well, what is it? What did you get? Right? Or they just shut down emotionally. Any of those is really a stall. It's a stall. Remember, we said stalling is not connected to ability, right? It's connected to their math identity. Are they seeing themselves? Are they understanding and understanding how they fit into math in that situation? Again, this doesn't mean that your child is not capable. Y'all, it means that the learning structure is broken somewhere. And again, we just talked about where it usually is. It's usually the C of the CRA levels, right? So I want y'all to think about the last time you heard something like this. When you heard, I'm not good at math. If you've heard that recently, please type yes in the chat. If you've heard that recently, someone said, right, a young person around you said, I am not good at math, please type yes in the chat. Please do. While you're reflecting on it, I just really want to be clear and to reiterate that this is exactly the moment where identity starts to shift. It's subtle, but serious. Remember, we said this is where students start to make that quiet decision of either I'm going to survive this math thing or, okay, I'm really good at this. I'm thriving in this. So we're going to talk about a couple of reframes though. Like when you see the stall, now you know what to look for. And now you know what is actually happening. So we're going to talk about what to do to move past, to reframe when the stall happens. So instead of saying study harder, we can say, okay, well, let's slow down and make this visible, going back to the concrete, right? That's where we either the concrete or the representation, because chances are they stalled at the abstract phase, y'all. So that's what we go back and we encourage. Draw me a picture, right? Maybe talking through it, explaining, using objects, right? You saw the young man on the other video I shared using objects, and then also asking, okay, well, what do you notice? Did you notice any patterns? Okay, tell me more, right? So clarity can restore confidence faster than pressure does. Pressure is not going to restore confidence. It's not. But clarity will. Clarity will. All right. So another thing that actually helps is some language shift. I'm going to give you 3 things. So shifting in language. So avoiding identity labels, right? Because children listen very closely to the way adults talk about their abilities. They listen and they watch. right? Very carefully. So even phrases that are well-meaning can reinforce identity labels, right? They might think, well, I'm not a math person. If you hear, well, math just isn't your thing. I was never good at math either. So now we are passing on this math identity issue, right? But we're learning some phrases this evening to say instead, right? Because we want to make sure that we're avoiding these identity labels. So we can try saying, okay, well, let's slow down and let's look at how the problem is working. Talk to me about what you notice in the problem. What part of this makes sense to you so far? Let's figure out the next step together. The goal is never, never, ever, ever to rush to the answer, right? You want to help your child see their own thinking. When thinking becomes visible, right? So whatever they're thinking, they can touch and move stuff, they can show, whether it's virtual manipulatives, right? When thinking becomes visible, confidence begins to rebuild and it rebuilds faster. Step two, the way that we actually go about it, literally the strategy, y'all. So we're breaking work into visible reasoning steps. A lot of times when student gets stuck, it's at the abstract level, and to solve and to figure out what's going on feels like a huge leap, just one giant step. But while we're supporting as their adults, whether it's their classroom adult or someone at home, we help turn the problem back into smaller pieces. So instead of saying, okay, well, do you know how to do it? Right? First, what is the problem asking you to figure out? What do you notice about these numbers? Can you draw or model what's happening? What might the first step be? So those questions alone help students return to the structure and flow instead of just trying to guess or memorize. What rule am I supposed to be using now? Just making sure they're actually processing through. I want to pause and say this because third grade is a big jump, right? That's when we start. That's when multiplication and division gets introduced to your math life. It is. So what happens a lot of times, especially when we come to the word problems, or sometimes some districts call them story problems, the young people are like, I don't know which one. I don't know what's happening. And so if they choose the wrong operation, then, well, yeah, they'll end up choosing the wrong answer. So the biggest hurdle in those situations, especially with some of the third graders I work with, is making sure they understand what's the story, right? It's a story problem, it's a word problem. What's the story? What's happening? So before I was like, don't talk to me about any numbers. Do not. In this problem, are we splitting things? Are we sharing? Or are we putting groups together? Do y'all hear the shift in the strand of conversation though? Right? Are we splitting? Are we sharing? Or is somebody sharing something? Are we putting things in bags? We're splitting things into bags? Or are we putting groups together? When the young people are able to articulate or are able to say, oh, Ms. Jones, they said that Israel and his two friends were sharing some snacks. Okay, so what operation does that sound like more so to you? Well, and everyone got an equal number of snacks, right? Well, that sounds like division. There we go. So just the consistency and them learning what to identify before getting to the numbers. Because I promise y'all, like, yes, it's math class, but I do not care about the numbers. I need you to understand what's happening first. Because we're not just going to circle numbers and jump. All right, so no ma'ams, no sirs, right? So making sure you understand the story part first. I want to take a moment to say that just in case anyone is supporting third grade and you may be catching this stream, because that is a big shift, right? If I've had some students that were having a hard time with that, we press pause. What is happening? What's happening in the story? Definitely. That's been tremendous for locking that in for them, for differentiating, right? Getting them to the point where now we can write the equation and solve it using your multiplication facts, right? Using your division facts or what you know about your fact family. But first we have to figure out What operation is it? Third thing, I took a little bit of a tangent on that one. Third thing, yeah, we're always want to protect their confidence. I keep saying that because there's so much goes into when young people are getting their identity together, whether it's in math class or outside of math class, right? And y'all know we care about them in all the places and spaces. So we want to make sure that we are protecting their confidence and that's ever present always on our mind. So with that, the biggest shift for a lot of adults, whether it's home adults or classroom adults, is celebrate their thinking and not the speed. I feel like I say this on every stream, but I can't say it enough because if it's a habit, you'll forget and you'll celebrate the speed. So I'm going to keep saying and keep giving ideas to make sure that we are celebrating the thinking, the effort, right? Not the speed. Because many children learn and it shows up super heavy. Upper elementary, middle school, many children learn that math success means that you got the answer quickly. Listen, you finished in 10 minutes, they finished in 35, y'all have the same score. What are we saying, right? But think about the reality of how that goes in math class or at homework time. Yes, time is an element, but we want to be clear that we value more, or we put more value, more emphasis on their thinking, their reasoning, right? Their process through it. Definitely. But again, because speed and understanding are not at all the same thing. Speed and understanding are not at all the same thing. But if we're not careful, young people think it is. Right? I raised my hand first. Now, this is what I got. Right? But often, especially like I keep talking about, especially the older they get, the upper elementary, middle school, high school, rushing, you can often make more mistakes, which will make the confidence worse, honestly. So we all need to pump our brakes on that. We all need to slow down, right? With making sure we're being careful about not celebrating speed. Honestly, I talk a little noise if students go a little too quickly. For me, I talk a little noise. I'm like, look, listen, I'll give a speeding ticket today because I need you to make sure that you're understood what was asked of you. You know what operations may be in play, and you have evidence, right? Because we have evidence to prove it. And okay, then now talk me through the process, please. Because all right, all I had to do was okay, talk because I will give a speeding ticket, and they know that I will. Let's see. Definitely hear the difference in the language. Ooh, that's powerful. Speed and understanding is not the same thing. It's not. And I keep saying this, and I especially check on it when, like I keep saying, middle school, high school, because that's when young people start getting maybe like honors classes and things like that, right? I'm in the GT class. It's the honors class. And so the competition, the competitiveness is going to exist in that space anyway. But one of the aspects, one of the ways that the competition exists is the speed. Who got the answer first? And so sometimes, it's fun, we gamify it and whoever, we're playing Jeopardy, right? But depending on if we're playing Jeopardy the real way, where someone has to buzz in first and then give the answer and all of that, versus, okay, team two gets to answer first, right? And then moving on. So there's different ways to take the time element out so that it's not as powerful. But sometimes that will be making some adjustments to the rules and things when we are playing games or when we are doing certain tasks. That's a quote. Less emphasis on not starting with looking at the numbers immediately takes some pressure off. And you listen, those kids give me side eyes sometimes. They're like, no number. Some of them put the numbers in the chat anyway. And I was like, I know I just said we're not worried about numbers. So they're trying to solve, but this is what I didn't ask. I didn't ask anything about any equations yet. I didn't ask you to write your math sentence. What is the story telling us? It takes the pressure off, but that has to be a learned, oh, we're not doing pressure right now. So imagine that if that's what you're used to and someone says, okay, no, we're not going to do it. Right. It's going to be a little bit of a struggle at first. before you're like, okay, so this is how to just purely think about the problem. And that's new a lot of times. It's different. So we have to give some time for that adjustment to be made as well. Yes to the speeding tickets. Yes. Because we're not doing that. We're not speeding through things. So again, instead of praising the speed, right? Because we don't want to give out speeding tickets. We're highlighting the effort and reasoning. So you might say something like, I like how you explain that. You know what? Your drawing helped to make it clearer. And I like how you use your vocabulary with the drawing. You labeled well, right? So you stayed with a hard problem. Good deal. Your thinking is getting stronger, right? Your thinking is developing, right? So sometimes your thinking is getting stronger. That looks like spot checks. When you started, right? When you started, how did you feel about this? Oh, I was at like a 1. I was all right. Well, how many stars would you give yourself now? You might not be at a 5-star rating, but how many stars would you give yourself now? Like a 3, maybe 3.5. Good deal, because that's progress, right? And that's what we strive for every time, just to grow a little more. That's it. So, great day today. Good day. It's new, it's different, it's learning. Yes, when we're not looking for those direct, what's the answer, what's your number sentence, taking all that off the table, right? Just going back to what is it asking you? What's happening in the story? Tell me in your own words. Definitely. Definitely it's new and it's different. But once they get it, they get it. And then we can build up from there. Great reinforcing comments. Thank you. So, on that note, y'all, those small acknowledgments that protects their identity, right, during moments of struggle. And as we said, during the moments of struggle, if their identity is not protected, they don't feel that safety and security, we're not processing that problem. We're not processing through this task at all. But if the identity is intact, right, the identity is growing stronger and developing well, then that is the part that keeps students coming back to work and to work on the problem longer tomorrow, right? Like, yeah, I struggled with something yesterday, but I got through it. It's okay. So now I'm going to try again today and see if something clicks, right? If we grow a little more today. So as confidence grows, that's because their thinking became visible. But if confidence drops, pressure, again, does not fix that. Pressure rarely fixes it. But like we talked about, the language, the structure, right? The chunks, and then the clarity behind it. So the visible part of your reasoning, those 3 things, clarity, structure, and language, y'all, that rebuilds identity surprisingly quickly. Like we can roll. Like once it's built and we're there, they know what to expect, right? The language has shifted, the structure. Oh, we're just focusing on this part first. Look, y'all, they're back. The confidence is back. That's exactly how it goes. So, this exact season, this exact reason, this conversation we're having about math identity, maybe what we need to rewind back to reinforce some things, right, to help our students, to support our student. Y'all, again, that's the exact reason why I created the Spring Reset Toolkit. So it reduces pressure, supports reasoning, and I can't say it enough, protects their identity even during the testing season, which can be stressful, which can, bring a lot of stuff, honestly. But it included and thought about, considered all of that. So the link for it is in the description, but I've just dropped it again there in the chat, and I'm going to pin it. Okay, so it's pinned at the top of the stream as well. But also, y'all, once you access that, right, once you get the Spring Reset Toolkit, there's also a parent playlist that has additional information, additional insights, just to reinforce the practical tools, because they're practical, they're right where you are. You can pick them up and use them day one, honestly, right? So, one final question. What if your child really isn't stuck, y'all? What if they're just missing that clarity piece, right? Because smart children don't stall because they lack ability. They stall when their identity gets shaken. So Identity can be rebuilt. We just talked about how. We talked about three things to reframe, to shift, to rebuild it. But again, I suggest the Spring Reset Toolkit as a starting point. Thank y'all so much for joining me this evening. Super excited about week 3. Week 3 is going to be really good. And I'll have another resource for you all as well to help to continue to help with the reinforcing comments, the questions, the positioning, right? A lot of our language work we're going to be talking about for week 3. But thank y'all so much. It was good. Hope you enjoyed it. And I'll see y'all later. Bye bye.